Okay, today we're going to talk about mole conversions. So before we do that, I'm going to do some converting of my own. I have my handy dandy magic thermometer wand here. And Mr. Bergman, he's nice and healthy. He brought a banana to eat today. I don't like bananas. I like brownies. So I think I'm going to try to convert this into a brownie. Tia-ha! Ah ha ha ha! There's my brownie. That's perfect. Now we can get on to some conversions. That's way better than a banana.
Well, I got my banana.
Yeah.
Yeah, it's good.
How'd you get that? I turned it into a brownie.
Well, with my magic, I converted it back.
Oh, that's pretty cool.
From your gut, because it was in your gut.
That's right.
So this is regurgitated brownie banana
That's
thing.
disgusting. Yuck. Yeah.
Okay. So podcast 3.3, we're going to be doing some mole conversions. All right, we want to convert between moles and grams and particles and liters.
Right, so we're going to be able to go to moles to grams, grams to moles, moles to particles, particles to moles,
Jeez.
moles to liters, and liters to moles. Everything goes to the mole.
Yeah.
When in doubt, convert to moles. First rule of chemistry.
So there's 3 conversion factors.
Yep.
Okay, and so you should definitely write these down.
Write them down, yep.
There's so many grams in a mole of a chemical. Now, let me kind of give an example here. So for example, if I've got nitrogen, N2, what would you do?
Well, there's 2 N's, so I'm going to look on my periodic table, and I'm going to get the mass of nitrogen, which is 14.
14.
And there's 2
But
of them, so multiply by 2. And that's 28 grams per mole. That's its molar mass.
So you'd say 28 grams of N2 in 1 mole of N2. Now, Mr. Sams, why do you write that as a fraction?
Because it is a gram per mole. It's a complex unit. We never do slashies. We always put one thing over another thing.
Exactly. A second conversion factor. The nice thing about this conversion factor, it doesn't change. It's always the same number.
Yep.
And that's the number of particles in 1 mole. And it's a big fancy number, 6.02 times 10 to the 23rd.
Yep.
Now, a review here. When you're doing this, it's very important that you understand that when you type in your calculator 6.02, you're going to use the E button, 23.
E23.
You do not say times 10. Never do times
Never.
10. And we've talked about that before,
Yep.
but it's going to become very critical here. And the last one is a pretty easy one. There's 22.4 liters of a gas in 1 mole of a gas. So, for example, nitrogen is a gas.
Yeah, it is.
So you can say 22.4 liters of nitrogen in 1 mole of nitrogen. It has to be just when it's in the gaseous state.
Right.
And it actually has to be, let's talk about this probably.
Yeah.
When it's at something called STP.
STP, that's right. That's one of your vocab words. If you're going through our packet,
Yep.
STP, you're going to need to look that up and figure out what it is. And if you haven't yet, that is 0 degrees Celsius.
So what does T stand for, though?
Temperature. Sorry, standard temperature and pressure, STP.
And so temperature would be
0 degrees Celsius.
0 Celsius, and the pressure is 1 atmosphere. Now, folks, if you're watching this in Woodland Park, where we live, we never live at 1 atmosphere
No.
pressure. We're about 0.75 typically, because we live high in the mountains at 8,500 feet-ish, somewhere in that range. So, but if you're at sea level, that typically is a pretty
Right
true
around
statement.
1, yeah. Okay, so we have those 3 conversion factors. Now,
Yep.
one thing we need to do with those is we have to be able to flip them over as well. So the
So
first
I
one
had
was
28
it was 28 grams
of
per
nitrogen
Yep.
in 1 mole of nitrogen.
Right. Now, sometimes you're going to need to put 1 mole on the top and 28 on the bottom, but as we learned in the last unit, you get to decide where the units go based on what needs to cancel out.
So really, it's the same thing,
Yeah.
right, Mr. Sams, but it's a little different.
Flipped over. Yeah.
Flippy.
Yeah.
Flippies. It's like flipping.
Flip-flop.
Flipper.
Flippy-floppy.
Flipper, he was like this guy who would... Yeah, that guy, yeah. Or you could
Why do I
say
always do the animal
1
sounds?
mole, because you're more animalistic than I am.
Oh, okay.
Is that a word?
I have no
6.02 times 10 to the 23rd
Right.
particles.
Particles
That's
in a
the
mole.
opposite of what we saw on the previous screen.
Yep.
Yeah, on the previous
On
screen.
the previous screen that
which-
just disappeared.
That just disappeared. Okay. Yeah. Okay. Great.
All right.
All right. We put this
Yeah.
the invert. So let's convert. Let's do some problems,
Let's
Mr.
do some
Sams.
examples. Yeah.
Okay. So what should we want to do? We want to just convert to moles.
Yeah. Let's
So-
take grams to mole.
Okay. So let's say I've got 6.3 grams of carbon dioxide, and I want to find the moles.
Okay. That's easy enough. Well, we're going to start by taking what we know and putting it over 1, just like
Right.
we've always done.
So 6.3 grams CO2. Now, I want to talk something about this. We've talked about naked numbers. Mm-hmm. Now, there's sort of naked and there's naked.
Yeah.
Okay. Now we're going to be kind of introducing the concept that you must not only just include the unit, grams
Right.
in this case, but also the chemical.
Right.
Carbon dioxide.
Grams of what?
Grams of carbon dioxide.
Right. So, yeah,
all right.
we've got Yeah, naked and then kind of partially naked.
So
but
now
we want
which
fully clothed.
fraction are we going to use? If we go back to our previous slide here, if I can find it, which particular one are we going to use?
Well, if I'm going from grams to moles, I want to use the one with grams and moles in it, and that's the molar mass one.
Yeah, so let's use the molar mass one.
All right, so we need to find the molar mass of carbon dioxide.
All right, so carbon has a mass of 12 from the periodic table, and oxygen is 16 from the periodic table. But there are two oxygens, so it'd be 16 plus 16 plus 12, or 12 plus 16 times 2.
Yep.
And I happen to know that's 44. So now it's 44 grams in a mole.
Right.
Now we can write that one of two ways, upside down or right side up.
Right. Well, the 44 goes with the grams, and it looks like grams needs to go on the bottom of this next little row.
Now, one thing I like to do, guys, is put the grams on the bottom first, and not worry about what number goes in there.
Right.
And then the moles, and I then go look over here and say, oh, 44 grams is attached. 44 is attached to the grams, and then moles.
And your numbers are partially naked.
And moles of CO2. Oh, I should have put some of my own clothes on.
Yep.
And I didn't do that.
There we go.
Okay, so the number on the bottom is there, so we should probably get our calculator out and
do
that. Oh, yeah. So what we're going to do is we're going to take in, what is it, be 12? No, 6.3.
No, 6.3.
6.3, and divide it by 44, and that's it. Okay, and so that equals, I guess I should have the pen turned the right direction. That's equal to 0.14
moles
of
carbon dioxide.
Of CO2. And what's the abbreviation for moles?
Mole.
Just MOL.
Yeah, mol.
You don't mol. You just don't put the E there. It's not a huge deal.
Yeah,
okay?
if you put the E, it's okay though.
Yeah, not a big deal.
I don't know why they abbreviate that.
Okay,
all
right, good.
Silly.
All right, what problem should you do now, Mr. Sanders?
Okay, well that time we went from grams to moles. Let's go the other direction. Let's go from moles to grams.
All right, so let's say we've got 3.2 times 10 to the negative 6th moles of diphosphorus pentoxide.
Ooh, okay.
Yeah, how about that one?
That's pretty fancy.
I know.
All right, so we need to go from moles. Let's go to, and we want to, I can't talk, turn that into grams. So we're going to take that number, we're going to put it over 1, 3.2 times 10 to the negative 6 moles, P2O5. Put it over 1, and now we're going to convert that into moles, or into grams, sorry, using the molar mass of P2O5, because that's how we go from grams to moles.
So I'm going to put moles on the bottom.
Right,
and grams on the top.
Now how do we figure out how many grams?
Well, it's P2O5, so I need to find the mass of P. P is 31.
Okay.
And there's PP.
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 Yes, 2 of them.
And there are 5 O's.
It's been a long day, can you tell?
Yeah, so you're going to say 2 times 16. Actually, I'll just do it over here. That's why the calculator.
I know, I was waiting for the calculator, and I forgot we had this fancy on-screen one.
2 times 16 plus.
Not 2 times 16, 5 times 16.
I knew that. All right, I'll start over. How about 2 times 31? That's
there
what
we go.
Say. Plus 5 times 16. And I get the big number of 142. Now that's going to go.
That goes with the grams.
With the grams.
142 grams per 1 mole.
And I just.
Now our moles cancel. So
I should really say P2O5. We're running out of space because the calculator is in the way. I'll try and write smaller.
Okay.
Okay, but now I'm going to type that into my calculator. So I'm going to say 3. Oops, I got a 7 there. How'd that happen? 3.2. Remember, we're going to do the second function, E. And it'd be negative 6 times 142. Gives me the grand total of
4.5 times 10 to the negative 4
times 10 to the minus 4th grams.
Yep, grams of P2O5.
O5. That's pretty easy, Mr. Sams.
Yeah, that's not too bad.
I can do that.
All right.
Sleep.
Okay, so that was
grams. I bet my students can. I don't know if yours can, but mine can.
Oh, mine can do it.
Yours probably can.
Yeah.
Too.
Okay, so that's grams to moles and moles to grams.
Okay.
So now let's try grams, not grams, particles to moles.
Okay, so let's say you've got 6.92 times 10 to the 25th atoms
of iron.
And I want to convert that to moles. Well, you're just going to start with what you know.
Yep.
Which is 6.92
times 10 to the 25th
times 10 to the 25th
atoms of iron.
You have to kind of write quite a bit here, don't you?
Yeah.
Too bad. Yeah.
All right.
And then the conversion factor we're going to use is the
Avogadro's number. 6.02 times 10 to the 23rd particles.
So atoms of Fe, and I put on the bottom.
Atoms are our particles.
And I'm going to go, an atom is a particle, so is a molecule.
Yep.
And then I'm going to say to moles
1 mole on the top.
of Fe.
Yep.
And this will be 1 mole. You might not, by the way, notice that guys, that 1 mole is attached to the, or the number 1 is attached to the mole in every case.
These. Yep. The number goes with the other thing. The mole always gets the 1.
At least in this chapter. Yeah. There'll be some changes next chapter. And that's it, because the atoms are going to cancel, and we're done.
Then we use our calculator.
So I'll type in 6.92 second E 25 divided by 6.02 second E 23. I'm going to get a pretty big number. 114.9, probably 3
sig
sigs.
figs, 115.
So the answer is 115 moles of iron.
That's a lot of iron.
That's a lot of iron. Okay. Okay, Mr. Sams, what if
Okay.
we had 0.025 moles?
Of chickens. Moles of chickens.
Oh, I can go that.
Yes. And you're probably thinking, what does chickens have to do?
Chickens.
Chickens. What
Yeah.
do chickens have to do with chemistry? Absolutely nothing.
But how many particles would there be?
It doesn't matter. That would be individual chickens.
All right, they're good. All right, 0.025 moles of chickens. I'll just say C. How about
Okay,
that?
moles
So-
of chickens.
And then we're just going to use that 6.02. So
Right,
I'll put
so-
moles of chickens to particles or pieces of chickens.
Right.
Individual chickens.
Right.
And of course, there's one mole,
mole,
and this is
and
that
Avogadro's number.
6.02 times 10 to the 23rd. Run out of space there.
Guys, my point here is that you can convert moles of anything into particles of anything using Avogadro's number because there are 6.02 times 10 to the 23rd of anything in 1 mole.
0.025 times 6.02. And do I push times 10?
Second E.
Never
Never times 10. Second
23.
E.
Oh, I switched to Spanish there. 23.
That's pretty amazing.
I know, I'm pretty amazing with that bilingual nature there. 1.5. How many sig figs can I keep?
Looks like 2 sig figs. today, yeah.
Wait, well, I think there's 3.
No, leading zeros are not
Leading
significant.
zeros. All right, yep. Times 10 to the 22nd. Chickens. That's pretty easy.
Yeah, that's a lot of chickens.
That's a lot of chickens. All right, let's say I have a balloon. This is, what was his name? Wilson or Wilbur? What was it? Wilson. Ever seen the movie Castaway?
Is that what that
with,
is? Yeah.
Tom Hanks? Yeah. So that's Wilson right there. He's a balloon.
You're starting to date yourself and me.
Well, I'm old.
Yeah.
I readily admit I'm old. I've got white hair. So let me see here. So let's say that Wilson has a volume of 16 liters.
16 liters, okay?
How many moles would be in Wilson's head?
I don't know, but I bet we can figure it out.
Yeah, so you just start with what you know, 16 liters over 1.
Uh-huh.
And that would be of, let's just say of air.
Of air, okay. Because air is a mixture of gases, but all gases behave the same way, so.
That's 16 point liters, okay. And so the new conversion, we haven't used this one,
Yeah,
so that's...
22.4 liters per 1 mole. Again, the 1 goes with the mole, and we're assuming this is at STP.
Yeah, we would assume that it
Yeah.
would probably say in the problem that it's at standard temperature and
Yeah.
pressure. So at 1 atmosphere and so sea level and kind of cold, 0 Celsius, which is
Cold
32
seaboard,
Fahrenheit.
yeah.
Like it is outside. It's a cold day out here in
It is
Park.
pretty chilly today.
So you'll take 16 and you divide by 22.4 because the 22.4 is in the bottom.
That's
It's pretty
easy.
simple.
Yeah, so the answer is 0.71 moles
0.71
of air.
moles of air. Yeah, I think we should do one more.
Let's do one more. Let's go we went from liters to moles. Let's go moles to liters, and we'll be done.
All right, so let's say we've got 5.3 times 10 to the 4th moles?
Moles.
Moles
Of oxygen.
Oxygen! I need oxygen! You know that in Woodland Park there's less oxygen than there is in other places. There's actually less oxygen here. Did you know that? That's because, of course, we live at high altitude. Taking a deep breathe. All right, Mr. Sams, take a deep breathe. Take a deep breathe. Very good. Okay, so start with what you know.
Okay.
5.3 times 10 to the 4th.
Moles of oxygen. Put
Moles
over 1.
O2 over 1.
Always put over 1.
And then I'm going to say moles on the bottom, moles of O2.
Yep.
And I'm going to say liters of O2. Assume it's at standard temperature and pressure.
Yep.
And
The 1 goes with the mole. I know that.
22.4 liters and 1 mole. So we're just
Yeah.
going to multiply these.
Yeah.
So we have a scientific notation. So 5.3, second function E, 4 it looks like, times 22.4 or 22.4 for you English speakers. Okay. 1.
Thinks he's clever.
187,200. Is that how I should write it?
I'd say probably 1.2 times 10
Yeah.
to the 1.
This would be better to say 1.2 times 10 to that. We're going to move the
6,
decimal
I
over.
think.
1, 2, 3, 4, 5, 6 times 10 to the 6th liters of O2. That's how you would write it appropriately
Right.
with the appropriate number of significant figures. Hey, I thought I had the white hair. What are you doing? You took my hair.
I think we're done.